Welcome to Talkin Science. Today, scientists now estimate that half of all sun-like stars have Earth-like planets. Now we hope they've had similar evolutionary paths and have complex life on them. Lunar's twin, astronomers now believe an asteroid hiding behind Mars and first found more than 20 years ago, is a long-lost relative of our moon. And snagging a magnetar, a super-dense neutron star, during a recent fast radio burst. How they did it may surprise you. Those stories and the headlines on today's 100th Talkin Science. It's Tuesday, November 10, 2020.
Beaming around the world with the latest science and space news on Facebook Watch, YouTube, and wherever you get your podcasts. This is Talkin Science with Dr. Brad Tucker and Matt Miller.
A very happy Talkin Science Tuesday to you, Dr. Brad Tucker.
Yeah, how's it going?
Really good, really good. What an awesome milestone we've accomplished today, mate. 100 episodes young.
Yeah, it's a good milestone. It creeps on you fast.
You know, when we started this show in April last year, I wasn't sure if there'd be enough content to fill the show every week, but there is just so much happening in the world of science and space that I never realised.
Yeah, and I think it just highlights just how much there is. You know, there's a lot going on, from the space exploration to the moon and Mars and the sun and obviously further astronomy and our Milky Way and our solar system. And that's going to keep going on. And I think it's a nice way to highlight it.
Yeah, absolutely. Well, plenty of stories to come today, so we better get cracking. Before that, though, you're on social media at btucker22 on Twitter, Dr. Brad Tucker on Facebook, I'm on Twitter at Merrimat86, and of course Trekzone, all over social media. Just search for Trekzone, like, follow and subscribe. Plus, ring the notification bell to get our latest eps straight to your feed. Brad, let's dive into the show.
Talking Science Headlines.
And Brad, first up in our headlines this week, we've made contact with Voyager 2 once again, now that the upgrade at Tidbinbilla has been completed. Some very exciting news for Glenn and the team down there.
Yeah, the big dish at Tidbinbilla, the NASA tracking station, down the road from me. And because it and the one in Goldstone are essentially the only ones capable still of reaching Voyager 2, with Voyager 2 and Voyager 1 being so far away, that when they returned it on after being online, they wanted to make contact with Voyager, just to tell it, you know, hey, don't be too lonely, we haven't forgotten about you. And right on cue, it said hello back.
Well, and given the distances that Voyager 2 has travelled, even in this time frame, it's remarkable that we've been able to make contact with it once again, lock onto it, and let it know that we're still out here.
You know, after months of no contact, if there was a slight drift in position or something happened, it could have taken a lot longer and been a lot harder to reestablish connection. So it's not just a given that, you know, you turn it on and dial to your favorite radio station and out pops it. It takes time for those things to happen.
Astronauts have arrived at the Kennedy Space Center over the weekend, getting ready for SpaceX's Crew 1 mission, which is going to be the first one to launch astronauts to the International Space Station. Of course, we had Demo 2 over the US summer. But now this is the first commercially operated mission.
Yeah, it's kind of the first normal full mission, not a demo mission where they will just be using it as their ride like people do the Soyuz, to go into space and do their stint in the space station, come back down. There will be 4 of them, including a Japanese astronaut. So there'll be 3 Americans and 1 Japanese. And, you know, this was supposed to happen last month. They had a few delays.
And they are gearing up for that launch. Like you said, after all these delays, November 14 US time. So it's going to be a pretty big launch, which is absolutely fantastic to see NASA getting back into the spirit of things and launching crews to the International Space Station from American soil. Fingers crossed that it's not like the last time a crew landed in the middle of something funky going on planet Earth.
Well, yeah, let's hope there's no surprises like the last astronauts who came down in the middle of coronavirus.
Of course, the astronauts have nothing to fear because the duration of this mission is certainly a lot less than what they have tested the Dragon capsule for in orbit. So any delays on the ground no worries, they can stay on the space station.
That's right. It can spend as much time as it needs up there. But yeah, so it's nice to see that fully going to service. That we saw the big effort that happened to get it established and to certified, and that's happened. So now really the question is, when's Boeing going to reach their milestone? Boeing and SpaceX were both developing it. SpaceX kind of pulled ahead, and then Boeing, when they had a few software problems, needed to do it. So, hopefully they'll be able to see their demo versions take place as we saw with SpaceX, so it can enter service as well. And then you have 2 in-service capsules ready to go, which means there'll be a lot of activity.
Certainly a fantastic time to be a part of the NASA astronaut corps, or even just a fan of crewed missions into low Earth orbit. Plenty of activity happening. Looking forward to that. All right, let's move to Chile for our final headline of the week. And unfortunately, the Arecibo Observatory has suffered some more catastrophic damage. Main support cable has given way over the weekend.
Yeah, there was earlier this year, I think it was August, an auxiliary main cable broke off, did some damage essentially underneath to part of the dish. If you can picture Arecibo, there's this huge parabola dish built into the mountain, and then you have the receiver and antenna that's supported over at top because they don't steer Arecibo, it's just built into the mountain. Well, one of those snapped and obviously did damage, and it's going to be a big task to get it fixed.
This really is a devastating blow for the observatory, as you say, suffering that auxiliary cable failure earlier in the year. Now this main cable, which just seemed to have been given so much more weight to hold on to, and it just gave way, which is really disappointing. But now they've got to get in and assess whether what the cost is going to be to repair all of this.
It's tricky, right? Arecibo has been obviously one of the biggest dishes, famous for being in GoldenEye in the Bond movie, if you ever saw it. But yeah, it's going to take a good amount of effort and money to fix it. So it will be something to see what they decide what to do with it.
And Brad, just lastly, in our headlines, I wanted to touch on something important that's happening here in Australia this week. We call it NAIDOC Week, and it's a recognition of the First Peoples of Australia and their contributions to everything before Europeans came along and did what they did. And there's some recognition of the first scientists and the first astronomers, with Parkes receiving a very special honour. There's
3 dishes at the Parkes Observatory. There's the main 70-meter dish plus a couple of smaller ones, and they were given, for really the first time, traditional Wiradjuri names in honour of NAIDOC Week and the land in Wiradjuri land where the Parkes Observatory sits. So definitely, paying respect and acknowledging the great scientific prowess, actually, to be honest, of the First Nations, the Aboriginal and Torres Strait Islanders, and the amazing things they've done in science and all around.
And that name that has been bestowed upon it is Murrayang, representing the sky world that it has scanned for more than 50 years. And I really hope that I'm getting that pronunciation right. And this is a significant step and something that will apply not just here in NAIDOC Week 2020, but permanently and moving forward, and recognising that the First Nations peoples were doing so much, as I say, in the fields of science and astronomy.
Definitely, yeah. I think it's going another good step to undo some of the past wrongs, but also, as you said, just more importantly, well, not more importantly, but really showing that, astronomy didn't start in Australia 50, 60, 70 X years ago. It's been going on for thousands and tens of thousands of years, and we're just continuing that legacy.
Talking Science, Stories of the Week.
Well, as Ross, our voiceover guy, said, Brad, it's time for the Stories of the Week in our 100th episode of Talkin Science. And first up, probably half of all the stars in the Milky Way, like our sun, the G-type stars, have planets like Earth, habitable planets in that Goldilocks zone, with the potential to hold complex life like ours.
Yeah, so what this was really looking at was kind of a population study of if we take sun-like stars, so in this case G and small G-type stars, so there's different types of stars, the sun's in the middle of its life. If we look at those smaller middle-aged stars, and it's about 5 to 8% of those stars are in the Milky Way, and there's about 300 billion stars in the Milky Way, so there's a lot of them. If we look at what kind of planets there are around specifically those stars, and again, we're focusing on our sun and planets like our Earth because this is the system that we know of that has life. How many are there? So therefore, how many could Sun-Earth systems there be to host life? And they're looking that, on average, it's probably about half of these planets could be rocky like Earth, orbiting stars like our sun. And I think that's actually quite exciting to think that there could be this many systems like the Earth and sun. If there's that many Earth-Sun systems, are there a lot more planets that could or do or have hosted life or supported life?
Yeah, and it comes down to the Drake equation, which works out how many communicable civilizations there are out there. And as scientific and astronomical research continues, we're learning more and more about all this sort of stuff. And I guess it comes down to data recorded from Kepler.
Yeah, so using Kepler data based on what they discovered of ratios of planets around other stars. So Kepler just looked at small patches, well, relatively small, they're actually still quite big, patches of sky to look for exoplanets, planets around other stars, and, found thousands of them with tens of thousands, really more. And then using another space telescope called Gaia, and Gaia really is mapping the exact location and movement of billions of stars, and kind of combining those and saying, all right, well, here's a good census, or here's a good sample of just what the actual star populations are in our Milky Way. And then we can already know of some of those stars what their rough ratios are of planets, and again, rocky planets. So we're talking about smaller planets nearer their star that are, anywhere between 0.5 to 1.5 times the size of the Earth. If you get bigger than that, you become a super Earth, which is actually a slightly different planet. It's not just special. It actually becomes a slightly different planet. And crunching the numbers, they get a pretty big number.
Yeah, well, the sheer volume is really tough to get your head around. There's so many planets out there. And if just some of those have the right ingredients and the right conditions, they could have had a similar evolution to our Earth. And all the sci-fi fans can now hold on to this research. There's got to be something out there, maybe.
Well, and as you said, with the going back to the Drake equation, when Frank Drake came up with that, one of the big goals was just to show, hey, it is worthwhile thinking and talking and looking for these things because the number is a real number. It's not zero. And when Kepler was launched back in 2009, we knew of exoplanets, but the question was just how many are there? How unique are there? We'd gone from, in 1992, the first discovery of any planet around another star, to 1995, really the first discovery of a planet around a normal sun-like star, which was the subject of the Nobel Prize the other year, to then saying, all right, there's planets out there, let's do it. And then, just Kepler kept really finding that planets are everywhere, that planets are the norm. And then, so the question is, when you look at the Drake equation, which says, all right, well, if we take how many stars are there in the Milky Way, and then how many of these stars are sun-like stars, and how many of those stars have planets like Earth, then how many of those planets could be habitable, how many of those planets could host life, how many of these planets could host intelligent life, and then how long would that life be around? What is the number you end up of potential semi-intelligent civilizations at a time in our galaxy? That went from 40, 50 years ago to really just telling people this is a worthwhile scientific question, to now starting to be able to plug actual numbers into this equation to actually get a calculation out of it and actually quantify this is how many we're starting to think of. And, we're building those numbers up to that equation and starting to understand more about the parameters for life. So it's definitely an exciting time in the field.
Now, this new research didn't factor in red dwarf stars, which make up about 3/4 of the Milky Way population, but they are trickier to live around.
Yeah, and one of the things that tests, and this is the the kind of replacement Kepler, it's been looking at lots of red dwarfs. And that argument was because there's lots of them. About 80% of the stars could be upwards of red dwarfs. So therefore it's the most common star, therefore it could host the most planets. However, red dwarfs they're fainter, they're cooler, they're more unstable in the sense that they're more prone to lots of flares meaning, solar storms or star storms and radiation, which really wouldn't be helpful for life because the star is smaller. The planet has to be closer because the key here is the potential habitable zone, that zone where it's not too hot, not too cold, so liquid water can exist. And if the star is smaller, then that habitable zone is going to be much closer to the star. And other things can happen when you're too close to the star. You can get what we call tidally locked. So that's exactly what happens with the moon. There's essentially always one side facing the star and one side facing away from the star. So, lots of different things that can happen that are just a bit different than the more generic vanilla type, smaller yet middle-aged stars that are longer lived and around more.
Now, Brad, next up this week, I want to say it's a chip off the old moon, but I can't take credit for that headline. But it does appear that there is something we found in Martian orbit that is a chip off the old moon.
So there appears to be that an asteroid, which is a relatively tiny one, about 1 kilometer wide, has been in orbit, around orbit Mars, essentially hiding there for who knows what. And in a catalog of one of these asteroids that was detected and looking at its composition, it was determined that the composition is eerily similar to that of the moon. And maybe this actually came from, was formed with, or is somehow related to the moon, and definitely, or at least really unlikely, not related to Mars, even though it's near Mars.
Yeah, this is a really interesting one. It was first found in 1998, but the Very Large Telescope in Chile has recently done some spectroscopic analysis on it, and it certainly does appear to be of the same composition as old Lunar.
It's a small asteroid that they've known for a while, as you said, but small asteroids mean they're faint and hard to see. So using the Very Large Telescopes, this 8-meter telescope in Chile, there's actually 4 of them as made from it, looking at really the composition, so seeing which signatures were present on the reflected sunlight, because anything you see in the sky is essentially reflected sunlight. And every element, every molecule, every chemical, so to speak, has its own signature, and you can look for those signatures and determine what it's made up of. In this case, they're able to see that what it's made up of appears to be the same stuff that what makes up the moon.
What I found interesting here is that it's a part of a group of objects called Trojans. Now, they're all hanging around Mars, but it's a bit different to the other Trojans in that they're all quite similar. This one is very different.
Yeah, that's right. In a slightly different movement and orbit, which is one of the reasons why they chose it. Clearly a slightly different composition, and they were also interested in just these Trojan asteroids, which, as you said, are just a different category of asteroid. They're not the traditional asteroids that get stuck in the asteroid belt. So learning a lot about it, and when we look at the formation of the moon was a collision between a protoplanet nicknamed Theia. This thing doesn't exist anymore. And the Earth ejected a whole bunch of rock that eventually got pulled together to form the moon. Here, was this formed at the same place? Did this form as part of the moon, and then a meteor or asteroid hit it and chipped it off, which is completely possible? Did something else happen? Obviously, way more questions than answers.
Well, the violent nature of the beginning of the solar system really throws up a range of possibilities of where it could have come from. Mars itself is being speculated, Theia, as you mentioned. But hopefully it is part of our moon, though, because it'd be nice to know there's another Earth moon out there. I've always said that Earth could do with 2 moons.
Well, look, we have known to have many moons as well. So, it's a changing scenario.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Just search for Trekzone.
Time for our last story of the week in our 100th episode, Brad. This one's really cool. Now, we've talked about them in the past. They're a cosmic mystery, fast radio bursts. Now it seems like part of that mystery may have been solved.
Yeah, there's been obviously various hints that it's related to some sort of very dense stellar object, either a small black hole or a neutron star, and something that rotates or orbits. As we talked about before, things that have a regular repeating signal pattern, in this case, fast radio bursts, especially the repeating ones, usually do a regular orbit or period, and that's the way to get that regular periodicity. There's obviously the class of fast radio bursts that are just kind of these one and done, we think, bursts. Lots of looking have been going into finding more, and obviously the hope to categorize them. And now a weak one, albeit that, appears to be spotted in the Milky Way. And because it was in the Milky Way, it was orders of magnitude easier to study and follow it up. It was slightly different than the other fast radio bursts, but the properties of it and the signs of it being similar to other fast radio bursts were there. And following up, it really was in the Milky Way. And it appears that it's a what we call a magnetar, which is related to an old neutron star.
And they are just incredible. In fact, I reckon they're probably my new favourite type of star. They're so dense that 1.5 times the mass of our sun is squeezed into an area no bigger than Manhattan.
Yeah, so when big stars explode, on the inside, gravity starts pulling the star inward and really squishes it all together. So it's kind of like, you take a scoop of sand and you just keep squeezing and squeezing and squeezing it. Well, the moment you stop squeezing is the moment you create a neutron star. You essentially squeeze all of the neutrons of that leftover bit of elements and bit of star fuel into a really densely packed ball. Then you kind of get this rebound, which produces a shock wave, and that ignites the rest of the star and explodes it. So in the explosions of some of these massive stars, you create neutron stars. And as you said, these things could be, half to 1.5 times the mass of our sun into something that's 10 to 20 kilometers wide. We're talking about a very dense area where if you were to take a teaspoon of it, it would weigh about 5 billion tons. And these things also can spin. And when you get a very spinning, magnetically charged neutron star, this is the magnetar. So imagine a really densely packed, small, tiny, super fast rotating. We're talking about on the scale of milliseconds star in space, all because of the explosion, blasting out bits of magnetism and therefore energy. We can see them, and the big ones that spin around we call pulsars. Magnetars have essentially just this super strong magnetic field and magnetism that really anything around it would just be destroyed magnetically. And so with all this happening, it appears that these fast radio burst signals are coming from these objects.
Now, while this isn't the first time we've traced the source of an FRB, it's the first one from inside the Milky Way, and it was discovered with two very different pieces of tech. I love this. One from a Californian doctoral student's homemade antennae using actual cake pans, and the other was a $20 million facility in Canada, just really proving that you don't need expensive equipment to make astronomical discoveries.
No, look, to be honest, and the reason, this little home setup, which wasn't really a setup, it was a small way of trying to find signals in a huge area. So they were able to rig a little antenna that's able to see essentially a huge chunk of sky. Now, you're not going to be able to see a lot of detail, but you'll see if there's any quick burst of light. So, kind of the more narrow you focus, you can look at fainter, deeper light, but you can't see as much. So they're able to say, all right, well, we see this signal. It's clearly, if we can pick it up, it's clearly real. You tell a bigger telescope, in this case, CHIME in Canada, to say, hey, here's something going on. Go take a look at it. They're able to find it and then figure out, hey, yes, this indeed is something. It is in the Milky Way. And it appears to be related to fast radio bursts.
And it's all but confirmed now with 4 studies on this one published in the Nature Journal last week. But that's just for this fast radio burst. There are as many as 50 theories for what causes the others.
Yeah, and as you said, there's these single bursts, but there's also these repeating bursts that we've talked about, which could be related to, previously they think, maybe something involving orbiting black hole, so maybe a neutron star orbiting a black hole, at the end of stars' lives in these massive, compact, dense objects, they're clearly producing extra amounts of radiation. And this is what this is. It's just radiation. Everything's radiation. Light from the sun is radiation in space. And this is just in the form of these short bursts of radio waves that they're just now getting a handle on. No different to the discovery back in the 60s of pulsars by Ruby Payne Scott. So, lots of these things, sorry, not Ruby Payne Scott, Jocelyn Bell Burnell. Sorry, Ruby Payne Scott started radio astronomy. That these things are happening. There's very energetic things in these massive events of ends of stars. And it's an exciting time to start understanding them.
Now, this magnetar discovery in the Milky Way is intriguing because they're normally a part of the star birthing process, and the Milky Way just isn't really a stellar nursery anymore. So it's curious as to where this one came from.
Yeah, it really is trying to understand what these things are, how they're formed, and get a glimpse of them. And that's really the case. You're able to probe kind of two different things at once here.
Absolutely, Brad. Well, as I've said pretty much for the last 99 episodes, it is fun to pick apart the stories of the week with you. Looking forward to continuing to do that as we fast approach 2021. We're not looking at slowing down. So more stories of the week, more headlines to come as we race through triple digits here at Talkin' Science.
Great. Talk then.